Good morning, participants. Welcome everyone for this third day, 6-day faculty development program on emerging trends in sustainable manufacturing, advanced materials, and additive technologies. Today's session, Dr. Raghunathan, Session Manager, Friction R&D, Brakes India Private Limited, Chennai. Before getting into the session, I will have a brief introduction about our session. Dr. Vijay Raghunathan is employed Manager in Friction R&D at Brakes India Private Limited, Chennai. He has completed his engineering in mechanical engineering, engineering in computer integrated from Anna University in the year of and respectively. He is the rank holder in UG courses. He has completed his Doctor of Philosophy in the production engineering from National Institute of Technology, Tiruchirappalli, India, in the year of 2000. His research focused on developing and characterizing automobile brake friction composite in with academia and industry of the global. He has done his doctorate in tribological behavior of natural fiber-based polymeric composite from KMUTN. He has completed his LLB as a through part from Annamalai University, Chidambaram. He has awarded the Building Researcher Award for the Production Engineering in the year of 2020 by Tiruchirappalli. He has published more than articles in various SEI and Scope Text Journal. He has published many papers in the field, and he holds 2 Indian patent and 6 Indian design registrations, patent registrations. He has edited many books for Elsevier Publisher. He has served as the associate academic editor, editorial board member for various SIE and the Scopus Index journals. He was the guest editor for the various special issues in SEI and the Scopus. He reviewed more than 200 regular and special issue articles in various international journals. Based on the Google Scholar, his citations are around 6,700 and his H-index is the maximum of 47 and his I-10 index is 83. With this great excellence, he has received the Best Research Paper Award 2020 from Friction Journal, indexed in Springer. An editorial contribution award. He received editorial contribution award from Scientific Report Springer, and he is top cited in India in the materials field by Material Research Express. Also, of his many articles as top cited in various journals. He is recognized by the Stanford University, USA, and Elsevier as one of the world top 2% scientists of the most cited scientist single year citation impact from 2021 to the till date. His research areas include brake friction composite, natural fiber and its composites, and additive manufacturing. On behalf of Veltech Multitech, Dr. Rangarajan, Dr. Saganthala Engineering College, Avadi, Chennai, I welcome Dr. Vijay Raghunathan for this today's session. The session is yours, sir. You can start your session, sir. Thank you.
Thank you, Dr. Arvind. It was a good detailing of my profile. So I hope all the participants has joined. Now it's the right time to start the session. So
yes, sir.
I'll just go ahead with the presentation. First one. So
I will stop my presentation, sir.
Yes. I hope my presentation is visible to you.
Yes, sir, it is visible, sir.
Yes, thank you. So, my presentation topic is about the brake friction materials. So, we all will be knowing automobiles, propulsion, how important is the propulsion. But at the same time, the rank 1 of severity index goes to not to propulsion, it goes to deceleration. Because once there is a panic situation, we need to decelerate the vehicle as early as possible to stop to rest. So in that situation, friction materials may be clutch disengagement, and mostly it is with brake, which plays a vital role in decelerating the kinetic energy. So with this small gist, I'll just go to the presentation. So next slide. So these are the overview of my presentation, where I will be giving an introduction about brake and its composite, what are the global regulations, past, present, and what is the journey of friction, brake friction. It includes past, present, and future. What are the types, how the brake friction composites are classified currently, then the classification of ingredients used in the friction material. Then now the current era is Euro 7, which is a pathway for BS7 regulations. So another thing, what is the manufacturing processes involved during the brake pad production, and characterization, and some case studies which I have done during my PhD and postdoc work. So then how to focus on the research in friction material, where we are and where we have to be. What are the insights that could be an sowing of seeds to the young minds to take up the field of friction. So this is the general introduction about a brake. As I said, it is based on the principles of energy, where energy can be neither created nor destroyed. It transforms to one form to another form. The same is here happening in the brake friction material. So, for a brake friction material, there are mainly, we have seen on our vehicles, that is four-wheelers, one will be disc brake, another one will be a drum brake. So, disc brake or drum brake, in the case of drum brake, the shoe will be internally sitting against the, what is that drum, so as to decelerate. In the case of disc, it will be having a pad which will be sliding against the disc so as to decelerate. So generally the brake is defined as a mechanical component used for converting kinetic energy into mechanical energy by friction. As I said in this thing, that is, as I said, one minute. I'm having something. So, is that screen is visible to you, please?
Yes, sir. It is visible, sir.
Yes. So, if you see here, as I said previously, the brake pad which will be housed here in the disc inside the caliper, when there is a situation for applying brakes, the driver will push the pedal in the case of hydraulic brake pad systems. So the driver will push the pedal, the oil will flow from the wheel cylinder to the caliper system, which caliper system will have a piston which will push the brake pad against the disc and it will decelerate. In the case of drum brake, it is the same thing, but here there will be a wheel cylinder which will be activated, and this wheel cylinder will push the lining towards the drum, which is shown here. So this drum, once the deceleration is over, the oil cutoff will be taken place and the return spring will happen. So as I said, for a passenger car, it's going to be a disc brake system in the case of front type, front wheel mostly, while the rear will have the drum brake. So disc brake is for fast deceleration, and the more energy will be, more push will be based on the rear side by brake. So the disc is mounted in the front, and nowadays it is common. They are mounting 4 wheels also in this. It happens. I'm just saying the general thing. So for this brake pad or a brake friction material to perform nicely, It should have certain qualities. First main quality is the coefficient of friction. So as the name suggests, it's a friction material. It should have coefficient of friction in the range of 0.35 to 0.45. So we used to range it as EEFFGG rating. So that is 0.3 to 0.35, 0.35 to 0.45, 0.45 to 55. Okay. So, sorry, 0.25 to 35, 35 to 45, 45 to 55. So 0.35 to 45, that is FF rating, is generally okay, because if it's more also, it will have more, what to say, it will erode the taste, it will bite, that is a bite it used to say, what we generally call as eating or cutting off. Like that will happen. Now this will not happen if it's this in range. So another thing is should have low fade and higher recovery. See, low fade in the sense when there is an increase in the temperature. So the brake is working in a higher temperature around 200 to 250 degrees Celsius generally. And if you go in 180 km per speed and brake, not to go to 350 also, depending on your pad and its mating condition, everything. In that situation, it should regenerate itself nicely, so that there won't be much loss when comparing the higher heating condition. So that it is said as low fade, higher recovery when it is decelerated, and if it is disengaged. So upon propulsion of the vehicle, so the air cooling or everything will happen. It has to regenerate nicely. Another thing is least sensitivity to mu, that is load, speed, humidity, then water conditions, oil, brake fluids, air pressure. Because we would have seen sometimes some drivers to even stand above the pedal itself. What's that situation is? That is the sensitivity problem which has happened. So there will be a different situation where the driver will be made to have a discomfort during braking. Another thing is that the service life. So lower the wear rate. The people will not be in a position to change brake pads. If it's roughly it's around 1,200 for a passenger car, till 4,000 it will have to go. Wearing application, wearing car profile, everything it happens. That situation, if I ask the member to change the pad for 5,000 kilometers, he will change us itself. He will say the pad itself will change. Not we will change the supplier itself, not the pad. So that is very important. We have to give a good service life. Then another thing is this is highly thermally stable it should be, because this is going to work in a situation where thermal stresses will be top, which will make the materials to have a disintegration or something, lose its property. So the material should be, that is the component should be how as the component will be. This is not a single component. Say as a cocktail of ingredients. Ingredients will be there in the formulation. So each ingredients will contribute to property, which will be explained in the next slides. Another thing is this pH problem. So on sharpness, we all will come up during the winter when we take up our hair or body, while coming out, the pick will stick still. Okay, it will like some discomfort. Rather than that, if you say first to start to break, the producers found called as each government buses are more prone to that one. And NDH problem will be very less. Because we are in an era of electrical vehicles where the cabin noise is going to be very, very, very less, which the pad has should not produce any noise, so that there will be no discomfort for the person who is driving the vehicle. That is, next one it should have a less VH. Then good conformability and compact. See, if it's going to have a drum liner, it might it should have compatibility with the mating surfaces, not by forming any scars or any pits around the surface of which it mates. Because the disc is around 4 times cost in compared to pad, and the frequency of changing disc is minimum twice the service life of our pad. So that has to be very much important. Now we are in the era of eco-friendliness. That is sustainability or any carbon footprints has to be reduced. So carbon footprints are very difficult to reduce. So we are in the process of making some sustainable materials like natural fiber based materials, or reusing of the waste which is produced, or reusing of the manufacturing waste itself from the brake pads in further formulations. Like that it happens. So this is the main thing for a requirement of a friction material. So now let's move on to the next slide.
Sir?
I don't think so. It is moving. 1 minute, please.
Yes, sir. Actually, slide is in the first slide.
Slide is in the first page itself. That is
Yes, sir,
brake
first
pad
page.
composite.
It is not moving, sir.
That you should have said in the starting itself. I have completed.
No, just stop presentation and you can reshare.
If there is any disparity, please be.
I will inform, sir.
Saying.
I will.
So I will be in a. I cannot see the presentation. Now is that visible? Brake and its composite.
Sir, brakes, types of brakes, one slide is there, sir. This is the slide which we are seeing from the beginning, sir.
Yes, that's what, that one I have stopped presenting. Now I have restated whether it is going brake and its composite.
No, sir. Still it is in the requirement of friction material.
Yes,
Yes,
that is
can you
only I am
change the
saying.
slide, sir?
That is only I am saying. The requirement of friction material, the topic is brakes and its composite.
Okay, sir. But after finishing this slide, it is not moving, sir.
I did not change. Now it's working?
Yeah, it is moving, sir. Now we can
Yes.
continue, sir. Thank you, sir.
Global freight friction composite market. I was saying about, now I go into the marketing point of view, maybe some guys from MBA or from management will think in a different perspective whether this market will have a scope in the future. Now I will come with the predictions which were done by Mordor Intelligence. So this report is from the Mordor Intelligence. So where automotive brake pad market currently is universal, that's global. So we are now in USD, it is expected 4.57 billion is the market. Now, by 2031, compounded annual growth rate seems to be USD 5.87 billions. So this is the thing what it's going to be the error. And if you see in the growth rate by region, there you will see mostly it is Asia Pacific, where the concentration is very, very, very high. That is, we own more automobiles. We often change our brake pads after service life. It's going to be, this travels car and all. They will change brake pads very often because they reach the service life soon. While our passenger cars, what we hold in our house, will not change very often. Maybe that 1 or 2 service after that we will change, not often. But this is the thing which has happened. For example, I'm saying market share by 2025, this is a report. So, see, 52.8 percentage is the mainly of what to say passenger cars. As I said, you have more passenger cars. Like commercial vehicle, it may be our what is that? We see that yeah, those and all. The Putiana used to say that vehicles like that will have some market share. So mainly our focus will be on a non-asbestos organic rather than semi-metallic. Semi-metallic is very good pickup new, but it has its own problem of corrosion and noise effect. I said, no, our government buses will have a good noise and even our vehicles. It is mainly due to the steel percentage which is there in the formulation. Which the problem is it produces corrosion despite of some inhibitors in the formulation. Rather than that, this stick slip phenomena and NVH is caused by steel. So now there are many research works which are companies and academicians and scientists have done to reduce the dependency of steel by restricting its percentage to every possible weight percentage lesser when compared to previous. Now there is a term called as low metallic or low steel formation style, which we will explain. So I hope now it is in the slide of automotive brake regulations worldwide. So yes, thank you. So in the case of decades of, this is all based on decades. Okay, from 2020 it's not based on decades, but till that it is on decades. So 1950s, early drum brake grinding formation by Henry Brund and team. So as he was the first founder of action automated brakes. Then we came up with a mechanical drum brake where asbestos was used. Then 1960 hydraulic brake regulations came. Then 1970 air brake system came for a heavy commercial vehicle. This is all worldwide regulations. So where it has happened, European Union or where and all it has happened. So 1980s is anti-locking braking system. 1990 ECR European customer regulation used to say for aftermarket parts which have a good friction level, wear rate and particulate emissions were also even important, but not much on particulates in 1990s. This came to picture for particulate emissions from 2020 only. So they were a good importance for giving the particulate emissions where Euro 6 and Euro 7 played a vital role. Now, Euro 7 is going very much stringent towards the particulate emission form, wear debris form by doing the braking and the tires. So 2000s it was ESC, electrical and stable control. I'm not much focusing on that things because it is out of scope of this study. So 2010 copper regulations, California bans copper in the brake pads. Now the people like us will come up with a question, copper, oh no, copper has got good antibacterial properties, good properties, conductivity, everything. Why it was banned? The forthcoming slides, this is a question mark for you to think and keep something. If you have any idea, you can say, or else I will explain you in the forthcoming slides. California and Washington regulations, what it said, and why copper was banned, restricted rather than to terms banned, it was restricted like that. Then 2020s, it was brake particulate emission, as I said, Euro 7 has come into picture. Like BS6, now we are in the era of BS7. We are going to be in BS7. Now the committee has been formed by the government of India, where it will happen maybe in a couple of years when the European Union enforces Euro 7 globally, preferably for the European business. Then we will be in the path of BS7, which will focus on the aspects of reducing the break gear debris percentage to 3 to 7 mg per kilometer. We will wonder how this will happen. That's the good challenge where we have to work on novel materials and novel formulations that will cater this. See, this 3 to 7 is not for all the things. EV will have 3 and some will have 7. Like that it varies. That 7 mg is not only brake pad, it is a combination of 3 materials. You have to wonder, how 3 mg? Wow. This 3 mg, if you see no pad, then it's going to be disc for your drum, followed by your tire. Tire is going to be the biggest problem for the tire manufacturers. There they have to focus much on the wear reduction to cater these regulations. So, journey of brake friction materials. So, as I said, when Henry Brood was finding out, there were only drum brake system. That drum brake system, previously that our cart charts when I was there. Like we used to say, no, horse cart, like that. They had a brake. That brakes was made of riveted leather, then cork, some metallic strips they used to make to stop the vehicle because the wheel rim was having. We all know that the wheel rim is metallic material. That time also it was metallic, so it was there. Then even asbestos was used when they came up in 1960s and 70s. Asbestos were used directly in the formation. Now we are in the current era of 21st century, where we are mainly focused on disc brake system and drum brake system. Of course, I say it is not there. So in that we have a 4 main category. One is semi-metallic, low metallic, ceramic, and so previous slide I did not say much because the name is self-explanatory. Where this was there, why lightweight, what it happened, what was the problems and all was given in the previous slide. Now it is in the present era we are in this thing. Semi-metallic will have steel, iron, copper, graphite and other fillers. So these fillers, what are the fillers, binders, fibers, and everything will be given in the next slide, how it is categorized. So for what it is done, what is the purpose, where it is there, cost economically, advantages and its own properties. Next one, as I said, to reduce the sound, are going for quieter operation by low metallic. So low metallic, we need to have a good wear and friction resistance also. That is done by this one, low metallic. Well, ceramic is for the high-speed cars, but the bonding, fillers, everything will be there. It's a quieter operation. For example, we can say that our BMW, Audi, Porsche, and Jaguar Land Rover. These are will have a good ceramic-based brake pads. It's called as elite pads. You can just simple we say, and for excellent comfort, weight resistance. But if you see the cost, it will be like gold cost, which is thrice or 4 times higher than the pads which we are seeing. Now, if it's going to be the global market or European market or US market, mostly focused on non-asbestos organic. So, organic fibers, ceramides, carbon fibers, glass fibers, everything will be used. Then resins, we have a phenolic resins, mostly widely is now used, and now studies have come up with to eradicate phenolic itself in the formulation, like inorganic fillers. Binders have been come. Then fillers, many materials like barytes. By simply filler means what you will say? Filler means something material. Normal grammatical English, filler means just to fill. Yes, of course, fill. But filling will have a 2 category. One is functional filler, another one is a filler, which I will explain. So low rotor wear, which is very important, wear resistance, and this is the main which is done by export market. India has its own in the case of some top brands of Tata, Maruti, Volkswagen, everything. It does and all it has. But to an extent, when it's going to be aftermarket, guys will go for one and two most because it's quite costly. Now, this is the part where many people has to focus, which will be the next hot topic next 5 years. When these European regulations is ready now, we will be pushing our people to work on this next generation. First one is the ventilated disc. So, this ventilation, they make some quotas, coatings, and everything.
Sir,
Yes.
sir, do you change your slide, sir? Still it is on brake friction materials in future.
Yes, I am in the brake friction material future only, I am saying.
Okay, sir. Okay.
Thank you, thank you. So, brake friction material future will be on ventilated disc. Rather than that, that is not our part. So, rather than that, we will be using a formulation of carbon ceramic, which is for high fade resistance, low wear, but cost will be very high. But even then, our premium cars will be requiring these sorts of things because a racing car and all, after one race, will throw up the pad, but they should perform very nice. So best for extreme performance as it's given here. So then is copper free low metallic, because copper, I said, it is having a regulation problem. So copper free will be focused, and even then bio-based materials is also given important. Now natural fibers, then bio-based resins are doing with some things, what to say, with some tooling. They are doing this for sustainable materials, like nanotechnology. Nanoparticles, though it is very costly and it is not currently used because there is no proper dispersion or utilization methods available at larger scale, so it is not used. But this will be next future. Many people are working on it. I hope the research community will come up with the good solutions to use it in a large scale in a couple of years. So, as I said, these metallic, currently we are focusing on 4 types. Low semi-metallic, low steel with non-asbestos organic, and it will have low steel. If it's low steel, there will be with the metallic materials, it will have some percentage of steel. If it's not low steel, any means they will have metallic material, but it is not steel, it may be some other materials which will be given. So this is the overview or types of friction material currently available: semi-metallic, low steel, NAO, low steel, and metallic and semi-metallic, ceramic. As I explained in the previous slide, this is just giving the applications and where it is used. So we have said that there is a friction materials. I hope the slide is moving to brake friction composites ingredients. Arvind sir, can you please confirm it?
Yes, sir. Yes, sir.
Yes, sir.
Thank you. So brake friction ingredients, which is mainly classified under 4 main categories: pastors, fibers, binders, pillars, and frictional modifiers. We all know that what is a fiber? Fiber is nothing but a reinforcement that is to withstand the structural integrity. So in that, our friction formulation will have 10 to 15 ingredients in the formulation. This is the formulator's strategy, what they will use. See, formulation is just a black science we used to say, because everyone will have a different strategy to make a formulation. It is just like making a coffee in a cafe coffee day, where same ingredients and milk, everything is being used. The coffee powder or some chocolate or something which is common. But the person who is doing that combination plays a vital role. A cafe day at Avadi will have a different taste sometimes, slight different taste, not much. I don't say that they vary much, but slightly may happen. And if you do the same at your home, just the same will be different. So like that, the formulator is having a own creativity with certain rules they will use it. So that is the thing. Where they will be using some fibers around a certain percentage based on the types what they are going to do. Semi-metallic or metallic or ceramic or any or those or like that. Then binders, which is as you say, name say binders. Binder is for binding the ingredients together. It is that's like a what to say, like a concrete column where the iron bars are the fibers. Okay? Cement is the binders, where you will put some jellies or something that is going to be a friction modifiers rather than that sand you are putting for integration. That is called as fillers. You can just have it in a rough way that is not exactly matches, but is for understanding the pieces. Fillers are of two types. One is inert fillers and another one is functional fillers. The list are given here. The inert fillers, for example, if the brake pad is holding around 110 grams to 120 grams of mix, one cavity, that it will have around 20 to 30% of inert filler to reduce the cost without compromising the quality. Okay. Then functional fillers, you have metal powders, calcium fillers for noise reduction, periplate for noise reduction, mica for thermal lubricity as well as thermal resistance. Many are there. Even metal powders are used. Okay, metal powders, like copper, brass, iron, tin. The culprit is when it mixes with this weird debris, having copper. When it mixes with the water, that make cupric hydroxide, which makes the salmons which is living in the Pacific to search the food chains. Okay, that is its sensory system gets damaged, which cut off around 110 food chain. It inclusive of the human which was having a indirect link based for fishing survival on that salmon. So they have restricted a copper usage, and in the bottom you can see how the copper usage is reduced. 2025 it should be 5%, 2021 0.5 to 5, 2025 lesser than 0.5. See, this is again a geo thing we have to think. If we see India or Asian countries, they will use copper. They will say we need copper for graduating heat everything. But not all. I should not say that all are doing the things, but some people does. But if it's going to be an European or some American, they will say don't. It depends. So there are some studies which uses copper and which restricts the usage of copper, and some studies which eradicates the usage of copper. So copper alternatives are given here. So NEO asbestos organic we have given. So there is a formulation to it. They will change the formulation, everything. Okay. So next we will go to the binders. As I said, it's a binder. It is used for binding the ingredients together. So one is the phenolic resin. It is a straight phenolic resin. It has some bonds of OH. How the typical composition will be. And some it is having a modified phenolic resins where we will be having rubber modified, novalic resin, glycol modified, epoxy modified. It's very cheaper. We cannot buy everything in what is it, Tetrapy shop. No? That's not possible. Like that it is also there. But universally the formulators will use both. Depending on the application, depending on the request, depending on the condition it has to work, everything. Okay. It's not a single factor, it's a multiple factor. the future of blinders. So this is a research area which people can focus their first one is the evolution of roadmap. You can see it at the bottom, which is other things are important. I say first one. Phenolic resin, advanced phenolic, how it is there. Now engineering, how they are putting nanomaterials also. Now they are planning, they are doing for the CNT, graphene, nanoclay based binders, the formulation for height strength. Then eco-friendly binders like the CNSL based and other recycled polymers, everything is used. But recycled thermoplastics are not generally used in commercial brake pads, but some low temperature applications they are using, not for brake pads directly to the automobile brake pads, but brake pads is done, but it's not for automobile applications. Then self-healing we are using for binders, damage sensing binders, everything that's done. It's a smart intelligence binder. I am not much into this one because this is all like a theory, but it is not fully into picture. Multi-phase, phenolic plus epoxy, phenolic plus rubber, epoxy plus ceramic. Epoxy plus ceramic means epoxy plus ceramic plus that phenolic is in the picture. Okay. So our polymer and nanofillers, like that multi-phase is in the picture. There are many studies which are going on, which can be a good pathway for the next form of research. So inert fillers and functional fillers, I said, 5 years. So inert fillers provide a bulk that reduce cost, improve dimensional stability, like that. I hope the slide is now when inert and functional fillers used in brake pads, right? Right, Mr. By Dr. Arvind sir. Can anyone say? Is it in inert and functional fillers used in brake pads, please? Audience?
Yes, sir.
Yes, thank you, thank you. So inert fillers, which is for non-reactive and structurally stable, as I said, it should not also hinder the performance of the brake pads. Barium sulfate is used, calcium carbonate, talc, china clay, magnesium oxide. This magnesium oxide, no, it's a culprit guy. It has both function of inert as well as filler function. So they will be present both in inert and filler, like cashew sections as metallic powders, ceramics, everything. So this is the general thing. So abrasives and solid lubricants, as I said previously, lubricant. Guy will come with some guys, I don't say all, some guys will come up with a question that so lube, it is for reducing. Yes, it is reducing. It is not reducing, it is stabilizing. That is reducing frictional function, friction fluctuation is stabilizing. So graphite based or metallic sulfide or this soft metallic lubricants, the boron nitrate, everything they are using. Abrasives for oxide and oxide based and non-oxide based, everything is there. How it will happen? Initial contact, how stable braking, plateau formation, everything is there. So now comes the main feature of current hot topic, which is the biggest problem next to copper and asbestos. Asbestos is gone, nothing. Copper is in pathway. Now a new day has come. It's called as antimony trisulfide. A geopolitically driven, health concern based, environmental concern based guy is this antimony trisulfide. Technically, if you see antimony trisulfide, it's a good solid lubricant with a high temperature resistance, everything. But what this guy does, this guy has an important problem in our health concern. That is this guy having SBM. It inflates the particle, it causes carcinogenic nature, and it creates many lung diseases like our asbestos guy who did a good way during his previous tenure. Environmental, okay, toxicity to the life, heavy metal concentration. You see fishes, sometimes they will say lead is affected, arsenic is affected in our fish while eating it. Our studies of marine studies will say that. Supply chain, okay, geopolitically, We had some issues with the state of most like that. That was not a big concern for this one, but some countries would geopolitically, centrically hold this material and stops the supply chain. So what they are doing? Now we are into alternates. Alternates, molybdenum disulfate, tungsten disulfate, copper disulfate. This cannot be made directly actually. Now. Molybdenum disulfate is too costly. Antimony trisulfate, if I buy it the 1 kg for around I can say 3,500, 3,000 I know. Means then this guy, molybdenum disulfate will come up with 4,500. Okay. So costlier, but it's good. Okay. Then complex sulfides, now we are in a path. Many studies are going on to use complex metal sulfides in the formulations. So this is going to be the pathway which is done for things. So how it will align with the SDG goals also is given here. Because our future will be all based on the SDG goals, Sustainable Development Goals of UN. Okay. Sustainable. As I was saying previously, sustainability. Now this is going to be the path. Sustainable breakdowns, life cycle assessment, how to reduce carbon footprint, how can we do. So sustainable natural fiber, plant-based fillers, recycling, carbon, bioresin, low impact additives. Because impact in the sense, we have some additives, we go for more intensive mining, open earth mining or underground mining, it will have a good impact on the it will have a good impact on the land. So rather than that, some abrasives can be used, recycled abrasives or something that can be used. Metal recycling is a good thing which we can try because metallic fibers are used, some scraps can be reused so that the reduction in the filling landfills can be prevented. Sustainable manufacturing, so as we know that the solar and the waste reduction, recycling, so this can get into the picture. Those researchers who are working on the sustainability and the life cycle assessment can focus some on this topic and get a good picture about the future. So Euro 7 regulations, as I said, how it's going to happen, what it is going to do, how many grams will be reduced. Euro 7, what it said, PM 2.5, PM 10 particulate emissions. How it is going to be. What are the pollutants which is combined? It's just an overview. You can get it from any of the open sources. So now comes the manufacturing of brake pads. So first one is a plow shear mixture, followed by preforming and curing, post-curing, and finishing. So this is going to be the picture of all the process. So first one is the mixing process. It will be done. I am just focusing on the current era of dry mixing process and dry materials only. We are not using any wet mixture or wet combination in any of the formulation in the current era. That era has stopped in 2010 itself. We are not now focusing on any liquid resins or liquid materials. The formulation where wet mix is going to be the different process which is completely eradicated in many of the manufacturing. Plow shear mixer where powdery ingredients, flaky ingredients, materials and fibers, fillers will be put, and at the end, they will be using binders to mix. Then it will go with the mixture where the chopper will be running. There will be sheet choppers which will be running in 3000 RPM with one shovel at 140 degrees, followed by weighing material composition. They will before also mixing they will weigh, and after weighing also they will weigh. Before mixing, they will fill based on the weight percentage and the formulation, what is the formulation weight percentage and the capacity of the mixer. Then after mixing, they will go for weighing, there they will be using the mixer combination. Preforming without heat, they will use hydraulic press. Then curing, they will use compression molding. Post curing, hot air removal. So there they will be having a step baking process, where curing they will be having a condensation polymerization reaction, where the temperatures will be defined based on the resin what is used to breed the cycle, and the curing time will be based on the thickness of the pad. Then pressures will be defined based on the trials and what is the green strength, everything what has to be needed, and they will do it. And finishing will be done by grinding and using diamond cutter. If they ask for putting a center cut, they will put center cut. It's not. This is the pad what you are seeing the outcome of this pad. So characterization of friction materials, which is an overview, is given here. Where we will be using all the standards which will be compliance with the IS, JASO, India I'm saying, okay, IS, JASO, even SAE standards compatible will be used, okay. Based on the customer requirement, based on the quality issues, quality we have to address. Rather than that, our Indian standard, internal standards, customer specific standard, everything will be there. Then is always dependent on the request, what our customer says, or generally if you say as an academic study, these are the tests which can be generally made. Thermal characterization, we need not have this much. Plasma ignition is sufficient. Okay? And water swell and heat swell can be eradicated if you want. Typological characterization also you can investigate. To pin on desk or chase test is enough. Inertia brake dynamometer, if you are going well and good, it's not there. Okay, fine. Academically. And for quality, industry will go till chase, they will not go for pin on desk because surface area of contact is very less. This is good. So high temperature, temperature variation and pressure variation can be studied by chase test, but pin on desk, very small sample, though you vary the seed and something, it will never even come to the RPM what it is running. Okay. So this is all the thing we will do. First one, physical characterization, and just read it out. Density, then used for making by arc distance for water swell. Well, how when the sample is kept inside the water for 30 minutes, how much is swell is there, porosity, acetone extraction, pH, shear strength, shear strength. Loss on ignition, thermogravimetric analysis, BSc will study the what is a melting temperature, everything, thermal conductivity, how much able to thermally conduct. Heat swell, one application of heat, how much it is swelling. Pin on desk will give values about the friction and wear. Overview based on generally with some changes in sliding speed, with some pressure and the load, that is load condition. While this chase test in PV quota RT, that is where the pressure will be varied with respect to temperature, but the speed remains constant. So the inertia brake dynamometer, this guy is the actual guy which an industry will do. What is this thing is, this is going to be having an inertia wheels which will produce the conditions of the vehicle mass, how it will be there, what is the vehicle load, inertia will be needed, speed, temperature, pressure, everything will be varied, and how the pad is performed. And our people will say, why I have to do all this test? I can put the pad directly in my vehicle and test. No, it's not easy. As per our Indian regulation norms, not only Indian regulation norms, it's a global regulation norms. You cannot put your pad directly in your vehicle and test, because this is a safety factor material which has a safety index as one. If something fails, if you go in a road and if you make a crash, the opposite person is also a victim, is also prone to some damage. This is not allowed. If we are going to do it, we have to qualify these all the tests. Then you can go up with the OEM customer. You can have a venture. See, this is not generally possible for an academician. I'm just saying for what people do. And don't say that I will do as an academician. It is not possible. There is certain standards in ISO that has to be passed, and ISO certification to be done. You have to have all the facility. Then only the OEM will have a business with you. OEM or local market, then you have a test tracks where you test it and you will put the pad and then only you can do it. Don't say that I have put in my vehicle and I have tested. If you are putting in the vehicle and if you publish it, it's liable to a law where some guys has done, but it's not in India. Some foreign countries they have done, but they have got what to say? They have got the permission. But India, it is generally liable to law, and it will create a problem of cases and everything. And morphological characterization, how the tribology has happened. This will be known from this. So the studies I said, physical characterization, density, what is the method, of how they will do it, it is all given here. The case of heat swell, it is based on IS 2742 Part 3 standard, where 10 into 10 into 10 4 mm sample will be placed 200 degree for 40 minutes they will do, and they will calculate in a muffle furnace. Then water swell. So cut in a pad 50 into 25, then soak it in 30 minutes, and then they will not be measured. So porosity, kindly know it is not internal porosity, it is surface porosity. Okay, the people may come, sir, porosity, it is a void. Void means the material is failing. Yes, the material is failing. I am saying about the surface porosity, not only internal porosity. Surface porosity is measured by this study, just D441, while the internal porosity has a tapping method and in the some other NDT method. If that does not pass, the pad is thrown out without any masses. So then these studies will be done. So chemical characterization, acetone extraction is to measure the unpure resin. I hope the slide is moving to acetone extraction. Anyone please?
Yes, sir. It is moving, sir.
Thank you. So pH test, because pH is in the culprit which will create a problem of corrosion. How acidic, how weak base, everything. This is the procedure. Then nowadays this is not using directly. They are not using this one witness paper. They are using the pH meters also. Procedure is entirely different, and it is customer specific and industry specific or what is it. It is all based on the requirements. Shear strength ISO 6312. How the pad will be having the shear value, how it will hold when it is going to cyclic stress conditions and all. It's given here. Hardness, generally two hardness are taken, R scale and K scale. If it's going to be highly hard material, it is K scale. If it is going to be it was soft like any one, it's R scale. Then this hardness, everything will be measured as per the standard procedure. This procedure is given in IS 2742 part. Okay. Loss on ignition 1 gram shall be weighted and 800 degrees Celsius in muffle furnace. Thermogravimetric analysis, how much fade, what is happening during the 150 to 400 degrees Celsius happen. So that's what we'll be showing. And the differential scanning and parameter also, which will give an idea about what is the reaction that is happening and what is the direct melting, what is the gas transition. Thermal conductivity, this is a laser flash apparatus which is used for measuring. This is based on Fourier law of heat conduction. So they will measure how much thermal conductivity is there, and based on the thermal conductivity, how much interface temperature is high. So the pin-on desk is shown here. This pin-on desk will have the pin for testing. So in that pin-on desk it is given here. The disk where it will rotate in a certain RPM, and the pin will be placed and the digital interface is given. So chase test where the sample will be cut into 25 into 25 and placed here in the holder. And it will be like a drum, and the braking conditions will be applied, and similarly you will get an idea. This is the chase test reset. As for SAE J61, it is on SAE J2752. Based on customer record, easily repetition. So this is a general schedule. So test procedure is given. We examine test. I said in the morning we keep it. After a rain, and if we come and keep it at the vehicle park for 2 days or 1 day, what will happen? Effectiveness study will be measured, and this is the dynamic. Okay. So morphological characterization on the dynamometer is tested. We will study the surface of that tested pad. What are the main wear mechanisms has taken place? Adhesion, abrasion, delamination, oxidation, everything. It's a cocktail of wear mechanism. It's not a single predominant mechanism. So primary plateau, secondary plateau, how this is formed, how the early step wear will happen, plateau formation, what is that, will stabilize, excessive wear means what will happen. Then what is the primary plateau, secondary plateau, all these is we will happen. You can refer my previously published PhD papers to get an idea. The copy is easy. So now I will go on to the case studies in brake friction material which I have done in my PhD in my postdoc. So it's fully on my academic study I have done. So first one I have done for liner using a stainless steel fiber as a replacement for steel fiber which was mainly for corrosion properties. So that time I tried with one top moving what to say utility vehicle where I tried with the formulation. This is the steel fiber and stainless steel fiber I brought from one of the Indian supplier. So we have tested it and how it is there, properties, everything is given here. Then if you see, this is the standards, so test procedure and these results are given. So I have given the average, actually I will test 5 to 6, 5 tests minimum and I will put the average here. Okay. The range alone for hardness I have, why I have put it, it is around 10 values. So I have put it as a range and not putting individual other things I have put as an average. Thermal conductivity, coefficient of friction number 2 times only, not much. I will not say that I have done for 3 times, it will not 5 times or 3 times. That is costly and I will not do it because that will not have more impact. Okay. So brake for if it is going to be a brake liner or not, for we will do it with various speed and condition. FM01 is steel based one and FM02 is the stainless steel based one. Undulations is lesser in the case of FM02 when compared to FM01. Okay. Bedded performances after certain application, around 400 applications, like our vehicle we will put the brake, start we will start, put brake, start we will start, brake, start, brake, start, like that, 400 application, after that there is a bedded performance. So it's all given in the value, so what is the undulations, everything, all the details are given. And fade and recovery process, FM01 and FM02 steel fibers, what is there, paid, how much it has faded, and what is the break factor value, everything. This case of stainless steel fiber, this is 0. So for all these, you can refer my PhD paper because in the overview, you not get idea. I have given all the theories, everything, and all the theories, everything in my PhD paper. For this one, I got best article award. So overview is that fade, how much it is calculated. Negative fade is not at all basic. Okay. Negative fade means will definitely cause speed because we are very well known that the steel will cause speed because this steel is a culprit will form what is that corrosion and the steel speeds or everything. Then this guy has to be carefully handled. Okay. So this is very thing. So we are brake jamming test in the morning. I'll spray it and I'll keep it for a while and how it has happened. You get an idea on the brake jamming test. Wear characteristics at higher temperature, at different temperature and speed conditions. This is the overview. It is a primary plateau is mainly made of thermally stable material, while the secondary plateau is made of silvery patches. These are made of less thermally stable. So this is the overview. I can say that FM02, that is stainless steel fiber based, was good for in the case of corrosion, but for performance and with no brake jamming. But cost wise is the same. Steel fiber is 2 times lesser when compared to stainless steel fiber. That is also very important in the case of commercial one. Academic research that does no way dependent on your money or usage. Your research, if it's going to be R&D, if it's going to be academic, Don't ever, never focus on cost. Some people will come up with a good point that, oh, what is this? This steel fiber is very less, while the stainless steel fiber is costlier. How can it be commercially viable? Commercially viable is not the researcher's point of view. While finding, you have to be. I will just go for the instance. We will be knowing pharma industry. Pharma industries, how much percentage of formulation get accepted? Can anyone say the number, please? A rough number. This is open to the forum. Can you say how much percentage of trials gets accepted despite of many trials? Roughly, any percentage? Audience, please. Audience, please. No. So I think audience are there.
Hello?
Can anyone say any number? You have any idea? Okay, fine, I will say because people are taking much time. It is around 2%. Okay, 100% if it's going to be the trials, only 2% will get accepted. That 2% only we are getting all the materials what we are getting. That amount is all based on that 98% of cost is spent on like that. So we can make it up. If it's going to be the current requirement, if something is happening and the government says 07 has to be implemented, you have to go for advanced knowledge, then it's fine. This will be a benchmark and you can make it as a commercialization and use it for an industry academia collaboration. That's what's happened. That happens in Europe or in abroad countries, but in India we are just lacking. If you see, even for PhD research, we don't call DC members from the industry or corporates. They say to the academicians, yes, we are having an academia where we are producing students to go and work for the society that is going to be the industry-based one. It's a practical one. We have to get inputs from the practical person. Rather than that, who was from academics, who comes to industry, has to be a bridgeway. There, the academics is also not supporting, and industry is also not supporting. The person government is making some initiatives to bridge that gap. Let's see. Can RF has taken any initiatives? So let's see for the best. So molybdenum disulfide, we studied with the various particle size during the PhD. So this during that one we have used coarse, fine and superfine grades. We have studied with the formulation. We have used around 6%. So this is going to be the TGA, which is not much thing. It will be like some water, like a wavy pattern, like sinusoidal waves. It will be perfect. So not much onto this. This is going to be the general heating equation. What has happened? So that's it. So density will measure everything as per IS 2742 Part 3 standards and hot shear, cold shear, porosity. This is all I did that for my own interest. It doesn't mean that you need to do all these 10 tests. 4 or 5 is maximum. Density, hardness, stone extraction, and porosity is much more important. Even you can add loss of mutation if you wish. Not much is important. Okay. For tribological characterization, for this I did it in chase is following IS 2742 standards, Part 4 standards, where what all happened, what is the friction formulation, what is the new normal. New normal is the at a normal ambient condition, what is going to be the friction value, 150 applications, what will happen. If it's going to be hot, at a higher temperature of fade cycles, it is happening. Fade cycle goes till 300 degrees Celsius. What happens? Recovery is from 300 to 93. That is normal temperature they will come. So then recovery rate. So what is going to be the overall performance? So based on that values, we will calculate the fade and recovery. There we have seen that the coarser material was performed good. Because it was able to form a good lubrication, everything, because the shear of values, everything was good. So despacing, as I said previously, the despacing was good for shearing the lubricants and liquid components. So these are the same studies where the wear debris, everything is done. So to map what has happened during your back transfer, whether any ion particles or something has taken place, we have made a study. So 3D profiles we have analyzed. So this is the values what we have got. Then in the case of C, that's going to be M1, the undulation is very less. M2, it has increased. But in M3, no, very much star was there because it was not lubricating very much. Stable friction was not there. So undulation was at peak. So this is given in this conclusion. I can say that M1 friction composite core-sized molybdenum disulfide would be a positive size. So various cashew friction dust, we will see that the conventional materials, cashew friction dust we got it from one supplier from China. So for noise suppression and thermal stability, here we studied mostly on thermal stability, not much on noise because that time we don't have facility for noise and it was not at the peak of doing noise. So how the friction dust are done? This study is published based on the Year of Materials Conference from USA, which we got funding to visit, and it is published in Year of LCS. So how this is anacardic acid polymerization, how it will happen, how they will tumble, everything is given here. So 5 grades we did that. One is CNSL, cashew natural liquid polymer, and the cardinal BFF raw based modified boron graphite. EGS such the results. So in that, boron graphite modified was getting a good bad because it has both thermally stable boron as well as lubricating graphite. So the same studies, everything was promising for that. The 3D surface roughness also. C5, if you see, it was very less. So surface roughness was very good. It was not having more undulations. So based on this study, we have given where the boron graphite, boron modified, CNSL modified, how it had, what are the problems as given. Everything is given in the conclusions. So next we went for the fillers, which is going to be pure natural barytes from various purity levels. The purity we got it from 3 different mines, 85, 90 and 95. So this is going to be natural barytes, what it happened, how it performed. They have done a dynamometer study for all this one. They are following JASIS eco-6 So based on that results. So the high purity material, we all know that the high purity material this will be good. But never ever assume that one in the future. Okay. Your postulates may fail many times in this friction. Example, one postulate I could say, higher heart is low wear. Okay, higher wear resistance. Definitely it will not happen. It will become a different area. See, the brake friction is defined as dynamic and aperiodic in nature. What to say? It is agaradi. In Tamil we used to say it's agaradi. We cannot put in this guy. This guy will do whatever he wants in the field. Okay. So this is all the field you can say. So we have studied and we have got the conclusion how 95% pure parrot for forming a lubrication everything was there. Now natural fiber based we have studied citrus lancing. It's on post-op study made cylinder and uncylindricated. I used in the formation around 10% and I have got the results. The cylinder was quite good. Okay. So now this we will just see YouTube video how the manufacturing will happen. I hope you can see that manufacturing of brake pads slide. Right? Video sir. Can anyone please say that? Please?
Sir?
This is the source from YouTube. This is all I will run. This is all about. This is the shop floor. So shot blasting is the process where we will use it for a brake backplate material. Okay, the piston material which piston will slide. This is the material which will slide with the piston. Okay, so there they will be using the shot blasting. There they will put that the shot blasting material. They will get that it will roll and it will come down. Okay, then they will apply the adhesive glue. This is the shot blasted one to remove grades, everything, and to make a better ultrasonic cleaning. So they will use to remove that any grit particles which is done. Then they will spread the glue. The glue conveyor they will put it and it will go 4 to 5 RPM. It will be rotating. It will be going. This there will be fast and once it goes inside, it will be very slow, very slow, very slow. You will glue it and you will heat it and come. So once it is done, they will make up. This is a direct fill process. There is no preforming. They will put this one in the molding machine. So once they will put the molding machine, they will level it with hand. But generally, we will not level it with hand. We will have some leveling things like scoops or something. We will have, and we will put the back plate, and we will put the compression molding. So this is how they will put the pad and weighing process. They will get an idea. Weighing process and the compression molded pads is there. They will apply pressure, then temperature, pressure, then breathing cycles, everything. Then they will load the keep that pads, and that is the molding of mold. Then there is a change in the profile. For example, if you are using for Skoda, if you are using for I-10, or if you are using for Jaguar, the process. This heat treatment is the post-curing process, where the post-curing will remove the residual stresses and some volatile materials. So this will be a big hot air oven which will be running with the step breaking process, which will have a different temperature from 140 to 160 to the ramp up. So spray paint is for aesthetic looks, which is not done in academics actually, but industry will do it. So if you want to have chamfering or snorting and something, grinding process they will use. This they have done chamfering. Center cut and chamfer they have for noise reduction and wear debris removal. This is shim bonding. Shim bonding will be for some supplier. They will ask for shim for reducing the noise, the battery plate, and preventing the noise to get propelled. It depends on customer, and wear indicator clips or everything is there. Then they will put into the grinding process. Center cut. Then they are doing grinding. Now the product testing, I said, so they will do for shear testing. This is a shear testing process. Then hardness, they will measure the hardness. Then compressibility. This is a indigenous friction test is what they have. This is a chase test machine. This is the sample what we showed. This is going to be the inertia brake dynamometer machine. This is all the commercial logo and packing, everything. Okay. So this is the thing. Now this inertia brake dynamometer, which is in United States, Alma Institute. This is the overview of the machine with all the inertia, the exposing, everything is given here. Was used in my PhD. During my PhD, the installation happened. So this inertia means everything. Here we will load the disc and the pad caliper systems, and all those machines will be inside. Okay. So research scope where you can focus it on. Like a rotor meter, engineer durability, environmental, some impact of future trends, testing, summarization. What are the things you can focus as a researcher? So by paper, publications, how many papers is published in 2026? I'm saying this till March, maybe till May. I did not get the latest status. So how many patents are there? It is mostly from United States only, most. This is from others, world intellectual properties from India, China, much is from United States. So now this is the period of electrical vehicles. Now the people will come. So electrical vehicle, regenerative braking, no problem. The conventional brake pad will be nothing will be removed. Okay. So, first the high-speed emergency situation, regenerative braking will not provide the braking force. There you need the conventional brake pads. Okay, maybe the service life or the time to time changing, service life will be extended. At low speed, regenerative braking is not good. So this is the lifespan. These are the things which has to be considered. EV pad can last more than miles. Okay, what now general pads are matched. Future of brakes. This is going to be the future. I come to the conclusion on the final slide. I especially thank Dr. M. Selvam, HOD Mechanical, Dr. Aravind and Mr. Satish and Mintech Multitech Mechanical team for giving me the opportunities and other things. And I should say clearly that this is all made only on from my PhD and the postdoc research which is published, and some images are developed from ChatGPT. This is not into the process of getting settled. It's only for professional services. For any queries, you can meet me to my personal email. Thank you for the opportunity.
Thank you, sir. So,
Yes.
so we will wait for audience questions, participants' questions. Then later we will conclude this session. Okay. So we will wait for a while. So, participants, so if you have any queries, please let us know. Vijay sir?
Yes, yes.
So there is
Yes.
questions in the chat box.
No, I could not see anything.
Yes, sir.
Okay, ceramic matrix for brake pad applications. Okay. Some materials means ceramic fibers you have, minerosilicate material, basalt based materials, everything can be used in the formulation. With high temperature resins, okay, ceramic means, so don't think that the ceramic matrix based matrix means here in brake pads, it is not only directly with the ceramic material itself. And in high aircraft materials, it is carbon, silicon, everything is done. That is also done. But generally, what now we are using in our current era for passenger car application is ceramic materials will be more when compared to this steel. We will remove it, and organic fibers and all we will remove it. We will increase more of mineral materials like some alumina or some ceramic fibers or rock wool fibers or basalt fibers or geowool fibers. There we will increase the percentage and alumina and abrasives which is our ceramic credit we will use it. Similarly, we will focus it on high temperature lubricants, not with the graphite. Graphite will lose its property around 500, 550, We will supplement by removing carbon dioxide and it will lose its property. We will not use high temperature. And this is the formulation type. You can focus it many things on wollastonite, mullite, kyanite, bayanite. That materials you can do as an academic. Okay. Is it okay?
Yes, ma'am.
Where can we get the facility for fabrication? So NIT Trichy has and many other academic institutions has. And some small industries also has that the part of you check it out. Openly I cannot say this. Thank you.
Okay, ma'am. Okay, sir.
Academically, I can say it is from NIT Trichy and many other academic institutions in Tamil Nadu has this business.
Participants, so if you have any other questions?
Is
There
there
is
the industrial standards? I don't understand. What is the industrial standards you say? If the person can be Mr. Arun Karthikeyan K. I hope he is Dr. Arun Karthikeyan or Mr. Arun Karthikeyan.
Yes, sir.
But it's Mr. Arun Karthikeyan K. He said, if they meeting the industrial standard means that is ISO standards. ISO standards they will meet. Industrial standards means I cannot say industrially one standard, because customer to customer, specific to specific, there will be variations. That is not needed for an academic research. Academic research need a standard profile and have a good controls about the production process. That is enough. If you want to do it on industrial large scale, generally that is not a big question mark, I would say. Any other questions, please?
Hello, sir. Yes, sir. So this is Dr. Arun Karthikeyan only, sir. So
Yes.
due to my mic, I am unable to
Yes,
connect.
can I have your just introduction? From which college or something?
Sir, actually, I'm Dr. Arun Karthikeyan, sir, working as assistant professor in mechanical engineering, CVM University, Gujarat, sir.
Okay, okay.
Okay. Actually, yes, sir, I'm working on metal matrix composite as well as ceramic matrix composite. I think in that I'm adding that boron carbide, silica, alumina, that alumina and silica. I mean, silica is extracted from agro wastes. So I'm making multiple combination into it, sir. Actually, if it is for brake application, what changes I have to do, sir, actually in this?
Especially the material what you are doing, no, it will not work for brake applications. Okay. So that material, if you want to work it, you can work it for not for automobile brake pads, you can work it for aircraft brake pad systems, you can work. Okay. Or for big brake pad systems, you can work. Doesn't mean that brake pad is not only for automobiles alone. It is for windmill, it is there, aircraft is there, or even for marines they have. Even for aerospace, that rocket launches, that has a friction material. That applications you can try. Okay. If you are going for an automobile application, you have to downsize all your process for phenolic based binding.
Okay, sir. Phenolic based binding.
Yes. That is a stringent thing where you have to do many trials. Where you need some technical person to support you. Okay. That it has to be built. That times preform will not come. Pure will have some blowholes, or matrix will not be there in a position to get. That all problem has to be tackled. That person should be kind enough in supporting you. Okay. I don't want to say there it will do or something. But if there needs many ifs and buts and trials where you will fail again and again, you will learn. Okay. If there is a guideway for you from that facility person, they can guide you. But I'm not sure how they will do it. It's all individual. Focus on aircraft brake pads, which is going to be having a good thing in the future, and the windmill brake pads. Now, next future will be on now we are in the green energy, no? There we will be using for windmills. That ceramic matrix will be a good scope in windmills.
Okay, sir. Okay.
Okay,
sir. Thank you, sir. I think it's a wonderful suggestion, sir. Try to explore more in this area, sir.
Yes,
Thank you for
of course. There are many literature papers from certain people who have done on things on aircraft brake pads and the windmill brake pads. Many have done, and more exploration is done by ANRF for that thing. You can apply for funding also. If you are a good expertise team with ceramic matrix, you can try. Okay.
Because as a matrix guy, as a composite guy, just we are trying to explore on some materials. Actually, we are not.
Yes, you can. Thank you.
But here we will have a brake pads. So if you are focusing on this, definitely we will get some output based. I think we will get some outcome.
Don't focus it on automobile brake pad. They will disqualify you. Okay. So as I said previously, some guys will make epoxy composite without finding an alternative. They will put it as brake pad application. Okay. Once it comes like a reviewer to me, I will tear the part. Okay. So that is very difficult. If you don't find a situation, we should not insert something which is not available. Like putting a garlic piece in the place of orange pulp. If you are putting a garlic piece, the shape doesn't meet, means it is waste. Okay, like that.
Okay, sir. Sure. Thank you, sir. I think definitely I will. I think I started following your Google Scholar and your purpose. Thank you. Thank you, sir. Thank you. Thanks. Okay.
Is there any questions, Dr. Aravind?
No, he is not having any questions, ma'am.
It was a very pleasure with you. Advantages of hydraulic brakes over air brake system. Hydraulic brakes is for passenger car application. While air brake is for heavy commercial vehicle, where you need to produce the air by compressor, which will be done by the air compressor, which is working for the buses or for higher vehicles. This hydraulic brakes cannot be used for heavy commercial vehicle. If you want to produce that much amount of pressure, you will be having the tanker size of tank in the fuel tank will be equal to the hydraulic tank what they are having for the vehicles, which is not possible. This is the hydraulic brake system. There is no direct advantages like that. See, everything has its own pros and consequences based on application. I don't say that the fish swims in the water is inferior to the cat which is walking in the land. Okay. So it is different. If the situation changes, it will fail. Okay. I think Soumya Rajan Panda, I hope you can get that answer. If further, you can just text me. Okay. In the mail. Dr. Arvind, we have come to the last
Yes, yes.
point, and thank you for your kind of wishes. Soumya Rajan Panda, kindly here. I'm not okay, madam. It is okay, sir. Thank you for your. Maybe my voice will be like it is in the decibel of 130 or 140, which is in the women's voice range, but it is not like that. Okay. Thank you. Okay, Mr. Arvind, I'll come to the
Sir,
point.
I think there is no questions from the audience, so we will
Yes,
conclude the session, sir.
thank you, thank you,
Okay,
thank you.
the way you delivered a session wonderful and insightful. So from the basic to advanced, importance of brakes, brake material, characteristics, testing and validation. So we believe the session undoubtedly helped the participants in research enrichment. So on behalf of Department of Mechanical Engineering, Management, Principal, so Well-Tech Multitech, Dr. Rangarajan, Dr. Sondala Engineering College. So my heartfelt thanks to Dr. Vijay Raghunandan, Assistant Manager, Friction Research and Development, Brakes India Limited, Chennai. So once again, I thank Dr. Vijay Raghunandan. Thank you for being with us in this FTP. Thank you, sir.
Yes, thank you, Dr. Arvind. I should also add a point. My first presentation during my BTech started with your Well-Tech Multitech. So I got a presentation award then in 2011 with for the breaks with your dynamic director Mr. Kishore Kumar and your chairperson Mr. Dr. Rangarajan sir. I could say it was a good feat, and now I should say that the stepping stone was from your side when I did my first symposium presentation on brake friction materials. Okay, thank you, thank you,
Thank you, thank you, thank you, sir.
thank you, sir. Thank you.
Thank you.
I will wind up the session, Dr. Arvind. Thank you.